So we are dealing with the topic of X-rays, and this is lecture number 2. I hope that we can complete X-rays in this class. In the last class, we had seen how X-rays are produced and how we can change the intensity of X-rays. Intensity means the number of X-rays. The number of X-rays or the intensity of X-rays is controlled by the current in the filament. The more is the current in the filament, the more is the heat generated and more are the electrons and more are the X-rays. If you want to control the quality of X-rays, hard or soft X-rays, high frequency X-rays or low frequency X-rays, you have to change the potential difference between the cathode and the anode. Do we remember this? In today's class, we will deal with the type of X-rays. It depends on how these X-rays are emitted. Hard and soft X-rays are based on their frequency. The next qualification is based on how these X-rays are produced. So the first of this type is known as continuous X-rays. Continuous X-rays. Now, what do you mean by continuous? Continuous means they are ranging from all wavelengths. They are X-rays possibly of all wavelengths above a certain minimum wavelength. Now, how are these X-rays produced? No one is going to ask you this, but still you can draw this diagram. Okay, no one is going to ask you this, but I will tell you how these X-rays are produced. Continuous X-rays. Now, how these X-rays are produced, we know that these fast moving electrons are going to, please listen to me, then you can draw. These fast moving electrons are moving towards the target element, target metal. Now, once they are moving towards the target element, they will collide. They will lose their energy in some form. Here, how they are losing their energy as they pass close through the nucleus of the atom. Do you see the nucleus of this atom? When this electron they pass close to the nucleus of the atom, they lose their energy continuously. Continuously they are using their energy, their path is getting deflected. Continuously the electron is getting deaccelerated. Continuously it is losing energy, and that loss in energy is emitted in the form of what? X-rays. These X-rays, my dear friends, are known as which type of X-rays? These X-rays are known as your continuous X-rays. Do we understand this? Do we understand why it is continuous? Because the electron is going to lose its energy continuously, and therefore you will have a continuous spectrum of X-ray. You will have a continuous spectrum of X-rays. Do we understand this?
Yes, sir.
Therefore, these X-rays are known as continuous X-ray. The electron passes close through the positive nucleus of atom. The electrons is deflected from its path. You can see that deflection. The electron is deflected from the path. This results in deacceleration of the electron. This loss in energy is emitted in the form of continuous X-rays. Note this down now. I'll give you 2 minutes. Let me know, beta, once you are done.
Done, sir.
What about boys? Have you done?
Yes, sir.
Okay. So here what you can see is electron is going to lose its energy continuously. Now, this electron has what we call, oops, wrong color. This electron has what we call as the kinetic energy. Yes or no? It has a kinetic energy half mv square. Now, this kinetic energy half mv square is actually coming from the potential difference between the cathode and the anode. Do we understand this? This electron, the kinetic energy of this electron is actually coming from the accelerating potential between the cathode and the anode. Do we understand this?
Yes, sir.
Okay. Now, in this type of continuous X-rays, there is a minimum wavelength or maximum frequency below which or above which no X-rays are emitted. So we can write minimum minimum wavelength. Minimum wavelength of X-rays. What is the minimum wavelength of X-rays which are emitted in this case? Now, the minimum wavelength will be emitted when it loses all of its energy. Do we understand this?
Yes, sir.
When it loses all of its energy, then it will emit X-rays of the highest frequency or the lowest wavelength. When will that happen? When its entire kinetic energy, half mv square, which is nothing but E into V, that is emitted in the form of X-rays, that becomes equal to the energy of X-rays, and that becomes equal to hc by lambda. Do we understand this?
Yes,
Yes,
sir.
sir.
This lambda will be the value of lambda min. So from here I can write the value of this lambda min as hc by E. Oh, sorry, hc by V, hc by E into V. Now, if I put everything in SI units, I will get the answer in meters, but I don't want the answer in meters. I will want the answer in Armstrong units. So we'll have that again, that shortcut 12,400 divided by V, and we will get the answer in Armstrong unit. Do we understand this?
Yes, sir.
Note this down. I'll give you 2 minutes.
Completed, sir.
Done, sir.
As soon as we talk about minimum wavelength, that means it will have maximum frequency. What will be the value of that maximum frequency? Anyone? Frequency max. Frequency max. It will be equal to EV divided by H. Do we understand this? Because this is equal to H into F max. We understand this, everyone?
Yes, sir.
So F max will be equal to E into V divided by H. So this continuous X-rays will have a minimum wavelength below which you will not have any X-ray emitted. Minimum wavelength here, normally we do not talk about frequency, we talk about the wavelength of X-ray. So there will be a minimum wavelength of X-ray below which there will be no X-ray, or there will be a maximum frequency of X-ray above which there will be no X-ray. Do we understand this? Yes or no?
Yes, sir.
What are the important points that you must remember in this? Has anyone noted this down? Anyone noted this down?
Yes, sir.
Important points. It consists of all wavelengths. This spectrum consists of all wavelength above lambda min. And how do I get the value of this lambda min? This lambda min is 12,400 divided by V in Armstrong unit. So this lambda min is inversely proportional to the voltage. Do we understand this, or this has gone above what I'm saying? Bye bye, I'm going, don't worry about me.
Understood, sir.
Remember, this entire chapter is about understanding and various graphs that you can draw. This is graph number 1. I will not explain because you can understand it. This is a graph between maximum frequency and the voltage. It is a straight line. Do we understand this? Yes or no?
Yes, sir.
You have to draw this, not understand this. You have to draw all these graphs because these graphs have come in your exam in one way or the other. The second graph is between log of F max and log of V. Again, it is a straight line, but not starting from 0 because log of something and 0 is not defined. Do we understand this?
Sir.
Remember the graphs, they are going to come. This chapter is all about graphs and this. I hope you understand all these graphs. Yes or no? No, yes.
Yes,
Huh?
sir. Sir.
This is graph number 3, drawn between lambda min and V, rectangular hyperbola, inversely proportional. And this is the fourth graph between log of lambda min, it is written lambda max, it is lambda min, and V. Do we understand all these 4 graphs? Yes or no? No, yes.
Yes.
I'll give you 2 minutes to note them down.
Done, sir.
Girls class, are we done?
Done, sir.
That takes us to the last and the most important graph which has come. This is the graph between intensity of X-rays and lambda, the wavelength of X-rays. What we can see in this graph, and this graph will come in your JEE Main or Advanced, if any graph comes. You can see here what I marked here. What I marked here. These 3 points, what I marked here. Huh? What are these 3
Lambda
points?
minimum.
Minimum lambda. Below this minimum lambda, there is no wavelength of X-ray emitted. Do we see this?
Yes, sir.
Now here what I have plotted the potential difference between cathode and anode. As you increase the potential difference, you can see lambda minimum is getting lower and lower. Do we understand this?
Yes, sir.
At the same time, this maximum intensity wala wavelength is also getting higher and higher, and it is going on the back side. That means this see, this continuous X-rays has all wavelengths possible above a minimum wavelength, but one particular wavelength will be maximum, and that is how it varies. Do we understand this?
Yes, sir.
Everyone has noted this down. Yes or no? No, yes.
Yes, sir. Done.
Done, sir. Then you can see for each voltage, the intensity curve start at a particular minimum value. Do we understand this? It rises rapidly, goes to a maximum and then falls, and it goes till infinity because all wavelengths would be emitted by this gentleman. I hope I have made my point pretty clear. Yes or no? No, yes.
Yes, sir.
Can I give you a question now? If you have noted it down.
1 minute.
Huh?
Done, sir.
Done, sir.
Done, sir. Then I can give you the question, sir. Yes or no, sir?
Yes, sir.
This is the question, sir. This is writing from your module, sir. An X-ray tube operates at 20 volt. This is the voltage between the cathode and the anode. The questions in this are very limited. Only 2 or 3 questions are there. A particle electron loses 5% of its kinetic energy to emit an X-ray photon. What is the wavelength corresponding to that photon? Now sometimes, chalo, have you done this question? 2 minutes you have. No one is able to do it. Should I do it? Yes, sir. No, sir. Huh?
Wait, sir.
Wait, sir. So much time, sir. We don't have so much time, sir. Life is moving ahead, sir. Do it fast, sir.
Do it, sir.
Do it, sir. Given up, sir. What is the
Sir,
Yes, beta.
1480 angstroms.
1480 Armstrong unit. Let me check from the answer. It is 12.4 Armstrong units. No one got the answer. So how you need to get the answer? This is how you should have done it. It operates at 20 kilowatt. So the kinetic energy of the electron that will be there, that will be equal to 20 into 10 raised to the power 3 electron volts. Do we understand this? It loses 5% of this energy. So how much energy is converted into photon energy? 5% of this. So this 5%, how much is the 5% of this? 20 into 10 raised to the power 3 into 5 by 100. That is the energy in electron volts. That must be equal to hc by lambda. So lambda becomes hc, that is 12,400 divided by everything is in electron volts. I just divide it. So this 2 and this 3 will become 1. 200 into 5, and the answer is 12.4 Armstrong units. How long it should have taken you to do this, bacha? What were you doing? Doing something else? Do you understand how this is done?
Yes, sir.
It has gone above our head saying bye bye. Don't worry about me. I'm going.
Understood, sir.
Understood, sir. What, sir? After reading, everyone understand that, sir. You have to understand before I tell you that, sir. Do we understand this, sir?
Yes, sir.
Okay, try this one. And I hope you can get this one at least. The only difference between this question and the previous one was this. They have asked minimum wavelength here. There they have asked what wavelength is emitted by that electron. They have asked now what is the minimum wavelength. This minimum wavelength is sometimes also known as cutoff wavelength. So please mind these words. Cutoff wavelength. Cutoff wavelength.
3.1 Armstrongs.
Chalo, everyone got this one correctly, quickly. That is great. So how we need to do this? Again, lambda in Armstrong unit is simply 12,400 divided by the voltage 40 into 10 raised to the power 3. As soon as you write it, you will get the answer as 3.1 Armstrong units. Do we understand this or this is gone above our heads? 3.1? No, 0.31 is the answer. Even I wrote in Josh. 0.31 Armstrong unit. That is the answer given to me. And I will not indulge myself in dividing it. We understand this or this has gone above our head saying bye bye? I'm going.
Understood, sir.
Okay. Shall we move ahead?
Yes, sir.
Now this is a
Right,
question.
sir.
Wait, sir. We are taking too much time, sir. It is not good, sir, for our health, sir. What you need to note down? You need to note down the calculation part, or you need to note down SC by lambda. What you need to note down in that question? Okay, I'll give you time. You have to get your speeds up, beta. You are pretty damn slow, and that is not going to help your cause, at least now. You have to speed up. I hope you're understanding what I'm saying. It's all for your good. See, if you can't do the questions fast
Done,
enough,
sir.
I will give you 2 or 3 questions less. Whose disadvantage it is then? It is yours. Please try
Done,
to
sir.
keep peace with the class. Okay, this is one question. Here, the cutoff wavelength, as I told you, cutoff wavelength. You must understand what is this cutoff wavelength. The cutoff wavelength for continuous X-rays from two Coolidge tube operating at 30 kilowatt, but using different target metals. Now, we have not discussed about the target metals, but they are using different target metals. One is molybdenum, and the other one is tungsten. Which is the correct answer? And you, for finding out this answer, you do not have to even use your copy and pen. You can give that answer straight away without using anything. And the answer is there is only one option which has same cutoff wavelength, and the answer is that option. You don't have to calculate it, because there is one thing that you have to understand. This minimum wavelength does not depend on the target metal. It only depends on what? You have drawn 4 graphs. There was no graph between metal and wavelength, metal and this. Yes or no?
Yes, sir.
That means it does not depend on the metal. And that is one thing that you must remember. In this question, you did not have to calculate anything, because there was only one option which had both the wavelength same, because this cutoff wavelength only depends on the operating voltage. And this is one point that you will note it down, and this was the question which was meant for this. Anyways, if there had been more than one options with the same wavelength, how would you calculate this? You would still calculate this in the same way, SC by V EV, or you can just simply calculate it by 12,400 divided by 30 kilo, and you will end up with this answer. Do we understand this, or this has gone above our head saying bye bye sir, I'm going? Huh?
Yes, sir.
Paka?
Pakka,
Yes,
sir.
sir.
Okay. Okay. So this minimum wavelength or this cutoff wavelength does not depend on the target metal. That means there must be something that depends on that target metal. And what are those? There must be something that depends on the target. And what is that? What is that thing that depends on the target metal?
Non-continuous X-rays.
Not non-continuous X-rays. They are known by this name, which tells us clearly that it depends on the metal. It is a characteristic of the metal, and that is why these X-rays are known as characteristics X-rays, because they tell us which metal is the target metal, because they depend on the target metal. They are the characteristics of the target metal. Therefore, these are known as characteristic X-rays. Do we understand this, or this is gone above by saying bye bye? Don't worry about me, I'm gone. Now, the process by which these X-rays are emitted is different from the process previously. In that previous process, what was happening was this electron was getting deflected by the nucleus. It was losing its energy continuously, and we had a continuous spectrum. Here, what happens? And this is what happens. Dung, 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 dung. Anyone can understand what has happened? So here is one electron which is obviously moving, and it is getting deflected towards the nucleus. Because of that, it is obviously emitting continuous X-rays. No one can stop it from emitting continuous X-rays. It will emit continuous X-rays, but something it has done here. But something also it has done here. Do you see this? Jing, 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 jing. What is the jing, 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 jing? It has actually collided with one of the inner shell electrons. It has collided with inner shell electron and imparted its and imparted the energy to this electron, and this electron has gone jing out. Do you understand this? This electron has been pushed out of the atom. Now this inner shell cannot remain free. So what will happen? The electrons in the outer shell, they say, okay, there is a vacancy, now we will fall. So what happens is the electron in the outer shell, higher energy level, they will be shifting to this energy, lower energy levels, and we have this ding 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 X-rays coming out of it. These X-rays are in addition to the X-rays which were happening because of that diverted path. These X-rays, because it depends on how many electrons are there inside, how many electrons will be knocked out. It depends on the metal. Therefore, these X-rays are known as characteristic X-rays. Do we understand this, or this has gone above what is saying? Bye bye. How are these X-rays produced? Do we understand this?
Yes, sir.
Sir.
What? So, if I have to describe it in short, this is how I'll describe it in short, and if you want, you can write it. So how are these characteristic X-rays produced? Characteristic X-rays come out when an inner shell electron has been knocked out of those inner shell. Inner shell electron has been knocked out and a higher electron occupies its space. That is how the characteristic X-rays are produced. Do we understand this, or this has gone above what it's saying? Bye bye. Both the processes are different. That pink thing is the diversion, deflection. It is still happening. But apart from that deflection, electrons are getting knocked out from inner shells. And that is why we have characteristic X-rays. Don't have to note down the entire Ramayana. You just have to understand what is happening here. Do you understand what is happening here?
Sir.
Inner shell electron are knocked off. Boom. Higher shell electrons are occupying a space. That's it. Shall we move ahead in life? Life has to move on. Huh? Shall we move on, or are we still? Shall we move ahead in life?
Yes, sir.
Sir.
Okay. Now comes the next point, K, L, M, and all these series electrons. All these series, not electrons, X-rays. What is this K, L, B, and so what happens in K series? Just remember this. Don't have to write everything down. What happens in this K series? There are 3 series in K series. Huh? K alpha, K beta, K gamma. So in this K series, what is going to happen? Please listen to me. Then you can copy from the board. What happens in this K series is an electron from the K series is pushed out. Electron from the K series is pushed out. So if electron from K series is pushed out, you can have a L series, a L shell electron jumping. You can have an M shell electron jumping. You can have an N shell electron jumping. Therefore, you have K alpha from L to M, L to K. You have K beta where the electron jumps from M to K, and you have K gamma when the electron jumps from N to gamma. Do we understand this?
Yes, sir.
3 series in K series. Similarly, we have the green series, which is the L series. In L series, what is going to happen? L series electron is pushed out, dung, 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 dung. Electrons will come from the outer shell, pung, 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 L alpha, L beta, L gamma. Then we have the M series. M series, M shell electron is pumped out, bang, bang, bang. Then dung, dung, dung. We understand this?
Yes, sir.
K, L, M. Alpha, beta, gamma, alpha, beta, gamma. Higher electron, The first higher shell is alpha, the second higher shell is beta, the third higher shell is gamma. We understand this?
Yes, sir.
Yes or no? No or yes?
Yes, sir.
Note this down. You just have to note this down. Don't have to write anything. Just note it down and understand what is happening. We'll give you 2 minutes to do it. Let me know once we are done. Everybody has understood this KLMN in series? Huh?
Yes, sir.
Sir.
Just this one diagram is more than enough. We don't have to write anything else.
Completed, sir.
Completed, sir. What about the other
Done,
students?
sir.
Sir? Done, sir? Done, sir, or no, sir?
No, sir.
No, sir. We are still hanging around, sir. Okay, sir. No problem, sir. I'll wait for you, sir.
Done, sir.
Done, sir. Then, sir, this formula, sir, this table, sir. This table is drawn for the K alpha, K beta, and L alpha. You can make it for other series as well, but these are the 3 series that normally come in your examination. All what happens in K alpha series? First see what I am speaking. Then write. What happens in this K alpha series? They jump from L to K. Do we understand this? So
Yes,
the
sir.
energy difference between L and K will be equal to H into frequency of that thing. If you want to find out lambda wavelength, it is Hc divided by El minus Ek. Hc is 12,400 divided by the energy levels between the energy difference between the two. In electron volts, if you put, you will get the answer for Armstrong unit straight away. Do you understand this?
Yes, sir.
For K beta, transition is from M to K. So energy difference is between M and K, and that same energy difference comes here. For L alpha, it is from M to L. Energy difference is between M and L, and that is the difference that comes over here. We understand this?
Yes, sir.
You have 2 minutes to note this down.
Sir,
Yes, bacha.
explain the energy once again, sir.
What energy? Which energy?
Energy of series.
Energy of is the energy
Series.
difference between L shell and K shell. It must be covered in chemistry, yes or no?
No, sir.
Just write it as energy level of L and energy level of K. It will be given to you, energy level of K and an energy level of L. K is the lowest energy shell, then we have L, we have M, N, and so on. It's not covered in chemistry, energy level, K, L, M, N. You have not, it's not covered there.
Not in depth, sir.
Not in depth. We don't need depth. We just need the energy of L shell and K shell. It will be given in the question. Don't worry about that. It will be given to you. Don't worry. EL. You must remember K is the lowest level. Do we know this?
Yes,
Then it
sir.
is L, then it is M, then it is N. That's it. You just have to write the values in electron volts. Do you know electron volts?
Yes, sir.
That's all we need. Don't worry. That is all that we need. We don't need anything else for this. Because if I start telling you the energy levels on the very beginning, I mean, I will take 3 or 4 class, because that's structure of atom. I have to tell you the entire structure of atom. I don't think we need it for this. That's why I'm not done. Shall we move ahead?
Right, sir.
Wait. Oh, done. Okay, I was thinking that I would be able to complete this in this class, and it's not going to get completed anyhow. Anyways, it will take one more class, not a problem. The important thing is that you understand and you are able to solve questions. If you can do that, it's okay.
Done,
Let
sir.
me know once you are done.
Done, sir.
Done, sir?
Yes, sir.
Okay, sir. Now you have to, I'll just write it here only, so that even if you are noting it down, you can note it down. Important points. This characteristic X-rays, the wavelength of this characteristic X-rays, this wavelength that we have got, does not depend on what? Does not depend on the operating voltage V. Do we see this? Yes or no?
Yes, sir.
It depends on what? It depends on the type of metal, because it depends on their difference in energy levels, and the difference in energy levels will be different for different metals. Do we understand this? Yes or no?
Yes, sir.
Okay, now I will show you a graph. If I show you this graph, which one should I show? This one. So now if I show you the graph, the actual graph of X-rays, when we have X-rays coming out from a Coolidge tube, the graph will look like this. Why does the graph look like this? It has some sharp peaks here. Why are these sharp peaks coming in this graph? Now, this is the total graph, the entire graph of X-rays coming out of this Coolidge tube. We have a continuous, we have this lambda min. Do we understand this lambda min? This lambda min depends on what?
Type of metal.
This lambda min depends on what?
Intense.
Huh?
Intensity.
It depends on the voltage, the operating voltage. We have done 3 problems on it as well. It depends on the operating voltage of the X-rays. It does not depend on the metal. So this lambda minimum only depends on the operating voltage. Now the spikes that you see are because of this characteristic X-rays. And these spikes come because of these characteristic X-rays, and these depends on the metal. Depending on the type of metal, these sharp spikes will come depending on the metal. I hope you understand this, and we'll
Sir.
keep in mind, beta. I get disappointed because we are putting in so much of energy and effort, but at the end of the day, if you just use the wrong word, it is all gone down the drain. Do we understand this, bacha?
Yes.
We'll just go down the drain and will be of no use. So I get disappointed because, anyways, lambda min depends on the operating voltage. Do we understand this?
Yes, sir.
Please remember this. Okay, and
Okay.
this is the actual graph, and I will show you this actual graph because it has the values of this alpha and beta series. So that is why I have shown you this graph. This same graph can come in your exam and they'll ask you which line is which. So remember which line is which. Remember which line is
Sir,
which.
show previous slide.
Hare Ram. Then if you don't complete, why do you say go ahead? Okay, read. Draw it. Drawn? We will do the next graph in the next class because it won't be possible for me to cover it. So the bottom line is
Sir,
this
no problem. Explain it. Another graph.
minimum lambda depends on the operating voltage, and the spikes which come is because of characteristic X-rays, and these spikes will be different for different metals. In the next class we will see the graph between the different series, and from there you will be able to understand which wavelength is less and which wavelength is more. So we'll do that in the next class. Don't worry. Take care. If you have any doubts, up till now, everything is clear to you, X-rays, for X-rays? Yes or no?
Yes, sir.
Okay, then we will complete X-rays in the next class. Don't worry, we'll do more questions from last year papers as well. So take care. Have a nice day. Bye-bye, everyone.
Bye, sir.